Hello, in this video I'm going to show you how you can send messages with Java from a Raspberry Pi to an online message broker. Now let's start with a short introduction of messaging. The heart of a messaging system is an application which acts as some kind of postbox. Other applications can send messages to this postbox or receive messages from it. This is called publishing and subscribing. In my book with Java examples on the Raspberry Pi, I created an example application to demonstrate this approach. There I used Mosquito as the messaging broker or the postbox and it was installed on a Raspberry Pi. But using Mosquito on a Raspberry Pi has both advantages and disadvantages. Of course, it's free, it's open source, it's easy to set up and it runs on a Raspberry Pi. Now the disadvantage, you always need to have your Raspberry Pi up and running. You also need to maintain it. And maybe it's not reachable for all the clients which want to connect to it and receive the messages from this broker. So let's use an alternative, HiveMQ Cloud. This online service is MQTT compatible, which means that it speaks the same language as Mosquito. Because it's a cloud service, you don't need an always-on server to manage and maintain. And another big advantage, HiveMQ Cloud is totally free up to 100 devices. So even for the most enthusiastic maker, that's a lot of microcontrollers or computers. On the HiveMQ website, you'll find a lot of example code for many programming languages. But hey, I'm a Java developer, so let's create an example with Java on the Raspberry Pi, of course. And yes, even the small Raspberry Pi Zero is a full Linux PC, so running Java on it is perfectly feasible. First step, we need to create a HiveMQ Cloud account. If you've done that, you will find your cluster. So this is your first instance of HiveMQ Cloud that we will use in this example. Now for this cluster, we need to create credentials, which we will use in our application. For this demo project, I'm using a CrowPi, which is a nice collection of pre-wired electronic components. You have to add a Raspberry Pi, in my case a version 4. We're going to make a Java application to run on this Pi. And to make our development easier, we are using the Pi4J library. This way the electronic components can be controlled as Java objects. The Pi4J project aims to unite Java programming with electronics. By using the Pi4J dependency in a project, electronic components connected to the GPIOs, the general purpose input and output pins of the Raspberry Pi, can be controlled as objects in the Java code. Pi4J uses native libraries to control the GPIOs, so you, as a programmer, don't need to be fully aware of all the magic which relates to hardware communication. The Pi4J website contains a lot of examples to get you started. And on top of that, an operating system which is based on the official Raspberry Pi OS, but with some handy improvements for the CrowPi. You can get the zip of this operating system from pi4j.com/download. You unzip it and use the Raspberry Pi Imager tool to burn it on an SD card. Again, on the Pi4J website, you can find a collection of CrowPi example applications for all the components. Now, the example application of this video is a remix of these examples. You can check the full source code in the GitHub project. The link is included in the description of this video and in the full article with all the info regarding this project. By cloning the sources from GitHub, you can build them directly on the Raspberry Pi and run them. As you can see in the logs, sensor values are sent with an interval, while others are linked to events with certain sensor value changes, like for instance the touch sensor or the tilt sensor, or when you come close to the proximity sensor. HiveMQ has a very handy WebSocket test page where you can connect with your cluster and subscribe to the topics where your data is published. Now you can see that data is coming in from our CrowPi. Now this is only the first step of this series. It's one more example of how great Java on the Raspberry Pi is. With a minimum of code, we have a running Java application on the Raspberry Pi to publish sensor values to the HiveMQ message broker. In the next post and video, we will use these messages to update a dashboard user interface.